Okay, now we're going to look at the solubility notes. This is the end of chapter 15-16. We do a couple of different things with solubility. We have these notes and we have the practice solubility worksheet that I will be doing with you guys as well. All right, so getting started on the solubility notes. Solubility is the maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. So there's only a certain amount of solute that a solution can hold. You'd see this if you were adding like sugar to your iced tea. If you kept adding teaspoons of sugar to your iced tea, eventually the solution will only hold so much sugar, and all the extra sugar would go to the bottom of your cup. That is because there's a maximum amount of sugar that the iced tea can hold. So that's a measure of solubility. Now, with solubility, we have three different types of solutions we're going to focus on. An unsaturated solution contains less than the maximum amount of solute particles that can be dissolved at a given temperature. That means that more solute can be dissolved when I add it to solution. Since it has less than the max, if I were to add more solute would be able to be dissolved then. A saturated solution is one that contains the maximum amount of solute particles that can be dissolved at a given temperature. Since it's already got the max, if I add more solute to the solution, extra solute is just going to fall to the bottom of the beaker. A supersaturated solution is kind of a phenomena. It's one that contains more than the maximum amount of solute particles, and they're all dissolved at a given temperature. So it's holding more than the max that it should, which makes it a very unstable solution. It should not be able to dissolve all that extra solute. In order to make this type of solution, what you would do is add extra solute, heat up the solution until all dissolved, and then cool it down. I will show you a demo. I'll post a video of a demo of a supersaturated solution for you so you can see what it looks like. So here's an image showing a supersaturated solution. Unsaturated, you can add more solute and it still dissolves. If it's saturated, you add solute and it goes to the bottom of the test tube there. If it's supersaturated to begin with, all the solute is dissolved. The way you can find out that it's supersaturated, though, is if you add a crystal of solute and you add a crystal of solute and it recrystallizes in the bottom of your test tube, then the solution would have been unsaturated. Then the solution would have been supersaturated to begin with. Once it has solute on the bottom, though, now it becomes a saturated solution. Here you see a couple of images describing solutions. On the image to the left, these are all water molecules there. And these particles here are your solute particles. Notice you have a lot of extra water molecules floating around that could still be surrounding solute particles. Because you could add more solute to this solution, this would be an image of an unsaturated solution. On the picture to the right, you could see that all of the solute particles are surrounded by water molecules. There's no extra water molecules floating around. So this one has the maximum amount of solute. It would be considered saturated then. Some factors that determine whether or not a substance is soluble. It's going to be the type of solute and solvent. So if it is polar versus non-polar, remember we looked at those ideas before. So if it's polar, it will dissolve other polar solutes. If it's non-polar, it will dissolve other non-polar solutes. But polar and non-polar will not dissolve each other. So that's that like dissolves like. Polar dissolves polar, non-polar dissolves non-polar, but polar and non-polar solutes will not dissolve each other. The next factor that affects solubility is temperature. Solid solubility usually increases with an increase of temperature. As you heat up a solution, it's able to hold more solute. Gas solubility, however, is opposite. Gas solubility is going to decrease with an increase in temperature. That's why warm pop is flat pop. When you heat up the temperature of pop, it can hold less. It decreases that gas solubility. So it holds less gas bubbles because it is increasing in temperature. The third factor that affects solubility is pressure. A change in pressure is going to have no effect on solids or liquids. So pressure has no effect on solids or liquid solubility. However, pressure does have an effect on gas solubility. It has a direct effect on gas solubility. So Henry's law states what this relationship looks like. Gas solubility is directly proportional to the pressure above a liquid. Therefore, and this should not be saying temperature, therefore, as pressure decreases, the solubility of a gas decreases and vice versa. That's why if you want to keep bubbles in your pop, you need to keep the lid on or keep the can closed, because that keeps it at a high pressure and it keeps the gas in. If you decrease that pressure by opening the can, the solubility of your gas is going to decrease as well, and the gas bubbles will disappear and the pop will go flat. Now, this graph here shows the effect of solubility of gases with temperature. As that temperature is increasing, so here they're showing you temperature is increasing, the gas solubility decreases here. You can see that they all decrease over time. Now, this has a direct effect on fish in water. So as that temperature is colder, let's say from 0 to 10 degrees Celsius, you can hold more oxygen in water. But as that water gets warmer, say 30 to 40 degrees Celsius, it holds less oxygen in the water. Fish in warm water then need less oxygen. Fish in cold water need more oxygen. So the temperature of the water really has an effect on what type of fish you can have in the water. All right, the last couple of ideas that we're going to look at is factors that affect the rate of solubility, how fast something dissolves. At higher temperatures, particles are moving faster. And the faster they move, the more the solvent particles are able to surround them and dissolve that solute even faster. Now, agitation is like if you're stirring or shaking a solution. When you add sugar to your iced tea, you stir it. You do that to get the molecular motion of the particles moving faster, and that allows for more contact between your solute and solvent particles and allows that solution to dissolve even faster. And then the last factor that increases the rate of solubility is increasing your surface area. If you grind up a sugar cube into smaller sugar particles, now those smaller particles are going to have more contact again between the solute and the solvent, and it will dissolve faster. All right, the next thing we're going to look at is solubility curve questions, and I am going to do that with you guys as a Google Meet Hangout. So we will look at that as well.